All right, so let's continue with some more simple algorithms. So this time, write an algorithm to check if a given positive integer is a power of 2 or not. You understand what's the power of 2? It's a number of the form 2 to the k, 2 raised to k. Okay. For instance, k is equal to 0 is also allowed. So 1 is also a power of 2 because it's 2 raised to 0. 1, 2, 4, 8, sorry, 1, 2, 4, 8, 16, 32, 64. These are all powers of 2. Okay, you understand that? So how do you check if a given number is a power of 2 or not? So let's call this power of 2 and the input is a number n. All right, so let's start. So this is the idea, right? If the number is a power of 2, 2 raised to k, let's start with 64. Okay, 64 is a power of 2. It is 2 raised to 6 if you check. 64 if you divide by 2, you get 32. 32 if you divide by 2, you get 16. 16 you divide by 2, 8. 8 divided by 2, 4. 4 divided by 2, 2. And 2 divided by 2, 1. Is that okay? All right, that's where you're reaching. So now in this sequence, what do you know? In the sequence, you know that at every step the number is even and you can go on dividing by 2, dividing by 2, dividing by 2 until the number becomes 1. Okay, until the number becomes 1. In between, at any stage, if you get an odd number, then you are wrong. Then it is not true. Then the number cannot be a power of 2. Is that okay? So here's the thing. So let's start with, let's say, n equal to 1 is a simple case. So if n equal to 1, just return true because it's a special case in some sense. Else, and now we begin with the main part. Okay, so what do you do? Right? So you just have to check if the number is even or odd, right? If it is even, you divide by 2. If it is odd, then we have a problem. Then the number cannot be power of 2. Is that correct? So again, let's do this. So we want to keep doing this for as long as the number is even, right? So while n mod 2 is not, sorry, is equal to 0, which means whenever the number is even, okay, whenever the number is even, you divide by 2, correct? So n is equal to n by 2. Okay, let's just keep doing that, nothing else. And while. When will this stop? This will stop when you have divided by 2, 2, 2, 2, and you have, so basically you have divided by a power of 2. And then when what remains is an odd number. Okay, what remains is an odd number. Now that odd number, if it is 1, then it's not a problem, right? If that odd number is 1, then actually it means you had 1 and then only a sequence of 2's before. So it is a power of 2. But if that number is greater than 1, it means you stopped at an odd number greater than 1. So an odd number greater than 1 is a factor of this number, which means that number is not a power of 2. Okay. It's a power of 2 if and only if all factors are 2. So there is no odd factor greater than 1. Okay, so that's all you have to check. So now after dividing by 2, end while says you cannot divide by 2 any further. You have reached an odd number. If that odd number is 1, then it's a power of 2, what we started with. But if it's an odd number greater than 1, then it is not a power of 2. Okay, that's all. So if now after this, if n equal to 1, return true. Else means n is greater than 1, but n has to be odd because the while loop has ended. So else return false. Okay, and that completes the end if and then the initial end if also. And that's all. That is the algorithm. Okay, so you can do one thing. You can take an example, as I said, and run this algorithm and check whether it works or not. Okay, so this is the explanation. Keep dividing by 2 until you get an odd number. If that odd number is 1, then there were no non-trivial odd factors, so the number is a power of 2. But if that odd number is greater than 1, it means there is a larger odd number which is a factor. So it's not a power of 2. Okay, that is the algorithm. All right. Okay, let's do another simple algorithm. Right, so here is what we have to do. Write an algorithm to do the following. Okay, what is it supposed to do? Given an array A, remove repetitions and give an array of distinct elements. You understand? Whichever elements are repeating, I'm supposed to remove them. Is that okay? So before I go into the algorithm is very, very simple. Okay, let me just explain to you the idea. So let's take an array. And we have to have repetition. So okay, so we have repetitions here, and this is an array. The idea is first sort the array by any method to get an array B. Okay, what is a sorted array in this case? So it's very easy to see. 1 appears 2 times, 2 appears 2 times, 4 appears 4 times, okay. 5 appears once, 6 appears twice, 7 appears once, and 9 appears once. Okay, this is the array. Okay, this is 13. 13 means 2, 3, 6. Yes. Okay. First, sort the array. Okay. Once we have sorted this out, what we do is the following. Now, the final answer is going to be this. Look at the first element. First element of B. We will put it as it is. Okay. From the second element onwards, what I'm going to do is I look at the difference of the next element with the previous element. And I will add the next element only if the difference is positive. See, it is sorted in ascending order, so this is increasing, right? So the next element minus previous element is going to be a non-negative number. If the difference is 0, it means the number has repeated. And if the difference is non-zero, which means the difference is positive, then it is a new number. It's a distinct number. That is the idea we use. Okay. So 1 I wrote. Next number is again 1, but 1 minus the earlier one is 0. So I'm not going to include it. Okay. 1 minus the earlier one is 0. So I'm not including it. Now I'm here. Now this 2 minus the previous one is 1. Right. Therefore, I'll include that too. Okay. Again, the next element I'm here, but this 2 minus the previous 2 is 0, so I'm not including it. Then I go to the next element. Now I'm at 4. 4 minus the previous element 2 is positive, so I'll include 4. Okay, I'm here. Now I go here. Next element. Again, 4 minus 4, 0. I don't do anything. Next element. Again, 4 minus 4, 0. I don't do anything. Next element. Again, 4 minus 4, 0. I don't do anything. Next element. Now 5 minus 4 is positive. So I'll include 5. Okay. Then next element. 6 minus 5, positive. So I'll include 6. Then next element 6 minus 6, 0. So I don't do anything. Sorry, I don't do anything. Sorry. Then next element 7, 7 minus 6, 1, positive. So I'll include 7. Then next element 9, 9 minus 7, positive. I'll include 9 and I will close this. Is that okay? Is that okay? So that is the array. Okay. So the idea is very, very simple. And now let's quickly write down the algorithm. Okay. So let's call this distinct. Okay. First step is to sort A and get a sorted array. So we'll use the quickest algorithm that we know, which is we can use any. Let's use quicksort. Okay. Any one algorithm is fine. We are using quicksort. So quicksort gives me the sorted array B. Now the array C, I don't know how long it's supposed to be. Okay, I don't know. So I'll just create an empty array C, okay, of whatever length. It could be infinite length. It's fine. Okay, so C empty, it could be infinite length. I just don't care. Okay, and how you implement it depends on the language. So C is empty. It's an infinite array with every element empty. All right. Okay. So that is it. So what is the first thing to do? Well, first element of the sorted array B1 goes as it is, right? So the first step is C1 is equal to B1. Is that okay? Now I do the loop. Now I am checking. Okay. Now I am checking. So let me fix a pointer J is equal to 1. Okay. And now I say for I equal to 1 to n B dot length minus 1. I'm not saying 1 to n because I don't know the length of B, whatever is that length. J equal to 1 to B dot length minus 1. Why am I saying B dot length minus 1? Because I'm going to compare B of I with B of I plus 1. Is that okay? So now this is the thing. If B of I plus 1, if the difference is positive, in other words, if it is greater than B of I, it is sorted, right? So if it is greater, okay, what do I need to do? Then I need to add this new element into the array, right? So the current pointer for C is J. J is at 1. Wherever that value is, I'll say J is equal to J plus 1. The pointer has been increased. Okay, the index of C has been increased by 1. So next slot. And then I'll say Cj is equal to B of I plus 1. Okay. And I do this only when Vi plus 1 is greater than Pi, otherwise I don't do it. Okay. And if. So J also increases only when Bi is B of I plus 1 is greater than B of I. Otherwise it doesn't increase. So this pointer is going to the right from here to here only when the difference is positive. When the difference is 0, this pointer is staying wherever it is. It is not going anywhere. Okay, it is staying wherever it is. Okay, so this is the case. And if, and that's what I have to do. I'm done basically. So end for. I'm just checking this throughout all the elements of B. So the for loop runs through I equal to 1 to B dot length minus 1. End for, and that is it. We are done, right? we are mostly done. The array C is now ready. So I'll just return C. Is that okay? I return C, and that is the array with sorted elements. It will also be in sorted order. That is just a bonus, but the elements will all be distinct. Okay. So that is the simple algorithm to get distinct elements or remove the repetitions.